عليكم ورحمة الله وبركاته. Dear students of the General Secondary Certificate, welcome back to your program مدرسة على الهواء. Firstly, let's welcome your guest and my guest, Mr. Muhammad Abdullah Riyad. Welcome back, Mr. Muhammad.
Welcome.
Dear students, today inshallah we'll discuss our lesson about Cyclo Alkanes and Benzene. Don't forget to get your copybook, your pen. Let's follow our teacher and listen to him carefully. Firstly, what's meant by cycloalkanes?
Any organic compound, any hydrocarbons has more than 2 carbon atoms can make cycle to close the chain of the carbon. So we can classify cyclohydrocarbons, all cyclic hydrocarbons, into 2 parts: saturated cyclic hydrocarbons and unsaturated cyclic hydrocarbons. Let's start with what's meant by saturated. Saturated cyclic hydrocarbons or saturated cyclohydrocarbons, we say that if the compound has more than 2 carbon atoms, 3 for example, and each carbon attached to 2 hydrogen, because we know that each carbon must have 4 single bonds. This is called cyclopropane. Cyclo because it forms cycle. Prop because it has 3 carbon. Propane because it is saturated. The general formula of saturated cyclohydrocarbons will be CnH2n, and this is called cycloalkane. Cycloalkane.
Actually, CnH2n similar to the alkenes, so we can call them isomers?
Yes, yes.
They are.
We'll make a comparison between normal propane or propene or cyclopropane.
So cycloalkanes and alkenes are isomers, have the same general formula, but different in structural formula, chemical properties, and physical properties.
This is normal propane. C3H8. Normal propane, and this is propene. C3H6 propene. Propene. The last one, cyclopropane. We can write a triangle to express the cyclopropane. What is the similar between the 3 compounds and what's the difference? They are equal in the number of carbon, so we called propane, propene, propane. Cyclopropane and normal propane are saturated, but they have different molecular formula. Cyclopropene C3H6, cyclopropane C3H6. Cyclopropane and propene are similar in the molecular formula C3H6, so they are isomer. But the difference between them, this is unsaturated while cyclopropane saturated. This is chain aliphatic compound and this is cyclic compound, chain compound and cyclic compound. The difference also between propane and normal propane and propene. The angle in cyclopropane is 60, the angle between bonds, while we know that the angle between propane or normal alkane 109. So with the angle less than 109, it will be partially overlapping. So the bond will be weak, can easily be broken. So cyclopropane is more active than normal propane. This is the difference between الألكان والcycloalkane.
And the question here coming the exam, give reason cyclopropane is more active than normal propane. The answer is, as you said before, because of the angle. Since the angle is less than 109 means that the compound is more active, so can broken easily. While the cyclopropane, while the propane, all the bonds are single sigma bond, a strong bond, hard to be broken. While the angle, the cyclopropane causes the activity of the molecule itself. Thank you, Mr. Mohammed.
When the overlap is completely overlap in the compound which have the angle 109, completely overlapping, make strong bond difficult to be broken. While in cyclopropane, the angle 60 means that the partially overlap, not complete overlapping between the orbitals. This makes the bond weak and it is more active, so it forms extremely burn in the air. This is about the cyclopropane. What's about the compound which have 4 carbon? This is cyclobutane. We can write cyclobutane like square, C4H8 cyclobutane. The angle here between bonds is 90, so it is more active than normal butane. When we write cyclopentane, the angle nearly to 109, so it is more active, less than a normal pentane, because the angle near to 109. And this is cyclohexane, C6H12 cyclohexane. We write this, and cyclopentane, C5H10. This is about the saturated cyclo compound, or cycloalkane. Cycloalkane, we know that the general formula CnH2n, CnH2n. This is called cycloalkanes. Let's write about the unsaturated hydrocarbons. Unsaturated hydrocarbons.
Actually, here we have a question said that cyclopentane and cyclohexane less active than cyclopropane and cyclobutane. As you said before, because of the angles.
Yes.
The angles of cyclopentane and cyclohexane is near to or more than 109, so this means that the molecule is more stable. So chemically does not, the stability is high, so it's not chemically active.
Like
while the cyclopropane and the cyclobutane, the angles less than 109. Actually, in cyclopropane it's 60, and in cyclobutane it's 90. So this less angles means weak overlap, as you said, so means that the molecule can easily broken and easily react. Actually, in one of the exams of the general secondary certificate, they have been asked, the students, mention one use of cyclopropane. Actually, cyclopropane is mixed with air to make a burning mixture.
Yes.
When it is mixed with air, it makes a burning, extremely burning mixture. So this is one use of cyclopropane. The student must remember it, because it is written in a very hidden place in the book.
No, it derives this from the property
yes,
of cyclopropane.
Yes. So the cyclopropane mixed with air and make extremely burned mixture. Now we'll transfer to the unsaturated cyclic compounds.
Yes.
Which is benzene.
Unsaturated cyclic hydrocarbon. the compound which has one or more double bonds. Let's see C6H6, which is benzene. This is a carbon. 1, 2, 3, 4, 5, 6. And each carbon attached to one hydrogen. So double bond and single bond, double bond, single bond, double bond. This is called benzene or aromatic benzene. Aromatic means a few number of hydrogen. The word aromatic means few number of hydrogen. Let's see another example and then explain how we get the hexagonal shape of benzene. Afwan. This compound is called naphthalene. Naphthalene has the formula C10H8. While another example, diphenyl has the formula C12H10. Here the number of hydrogen less than the number of carbon, so they are aromatic compounds. This the question in exam about to make a comparison between naphthalene and diphenyl. Naphthalene and diphenyl, we write the structure formula and we write the molecular formula. Let's know.
Actually, also in the naphthalene, as we see in the data show, the two benzene rings are fused. Yes. While in the biphenyl, there is a bond separate between them. So when we said an organic compound, aromatic compound has two fused rings, we write naphthalene. While in biphenyl, the two rings are separated by bond. Thank you.
Okay. We can write benzene like this. Or we write circular inside benzene ring. Actually, to get the cyclic shape of benzene takes several years. Auguste Kekuli write the shape of benzene like this. Because when we study the properties of benzene reacts by substitution, by addition. Substitution, we know that saturated compound react by substitution. And the addition, unsaturated compound reacts by addition reaction. Benzene reacts by both addition and substitution. This is number one. Number two, the bond between the carbon, 6 bonds are equal, and in between single bond and double bond. In between single bond and double bond. So the electron change its position from one carbon to another. So we make this to know that the double bond can change its position. So this is formula of this shape represents benzene, which is C6H6. So Auguste Kekuli reached to this formula. But take care that the difference between benzene and benzene. Benzene, the car fuel. Benzene, aromatic benzene C6H6. While gasoline or benzene, it is the mixture of heptane and isooctane. heptane C7H16 and C8H18. This mixture is called the gasoline, the benzene of car or fare of the car. This is unsaturated, but these are saturated compound. This is a cyclic, but these are chain compound, not cyclic. This is the difference. This aromatic and this aliphatic. Now, take care. There are a difference between aromatic benzene and benzene of cars, which is called gasoline, lower mixture of heptane and isooctane.
And also in the written, they're writing the word benzene, B-E-N-Z-E-N-E. While the benzene, the other benzene, or that we call it gasoline, it's B-E-N-Z-I-N-E.
Yes.
So the gasoline is Z-I-N-E, while the aromatic benzene Z-E-N-E. So the big difference. Yes.
Right. Now let's see the radical or atomic group from benzene. We know that benzene C6H6. So when we remove hydrogen, from benzene to be C6H5. This is called aryl group. Aryl, symbol AR. We take alkyl group R, let's see NH2N plus 1. But here C6H5 and bond, this is aryl group. It is called phenyl. The difference between vinyl and phenyl. So the phenyl C6H5. And this is aryl group or atomic group. They can attach by maybe chloro, phenyl chloride, phenyl bromide, phenyl alcohol, whatever. This is about the aryl group of benzene. Let's start with the preparation of benzene and then nomenclature of benzene. Preparation of benzene. Number 1, from coal tar. From coal tar. Coal, by heating coal, strongly heating in absence of air, this is called destructive distillation. Destructive distillation. Destructive distillation means strongly heating coal in absence of air. It gives many compounds, gases, solids, and liquid. We get coal tar. This is a liquid coal called coal tar. By fractional distillation of coal tar, fractional distillation, when we want to separate many liquids mixed together and they have different boiling point, we use fractional distillation. When the temperature from 80 to 82, it gives benzene. So we get benzene from coal tar by fractional distillation. This is number 1, how to prepare benzene. Number 2, prepare benzene from hydrocarbons. From hydrocarbons. Number 2, from hydrocarbons. A, from normal hexane. Normal hexane. Hexane C6H14. Using thermal catalytic reforming. Thermal catalytic reforming. يبقى reforming the shape of normal hexane using catalyst and using heat to give C6H6 plus 4H2. This is a normal hexane, 1, 2, 3, 4, 5, 6 carbon. During catalytic reforming, four molecules of hydrogen are removed. This is 2 atom removed to make double bond, and this removed to form double bond, and also this the third one to form double bond, and these are removed to complete the cycle or to form the cycle. So it will be C6H6 double single double single double single bond to be benzene. Double single double single double single. This process is called thermal catalytic reforming. Also from normal heptane we can get what's called toluene. We will take this later when we study the compounds of aromatic. Number B, from hydrocarbons also, from ethylene or acetylene. Acetylene C2H2, 3 molecules. We heat in red hot nickel tube. In red hot nickel tube, acetylene is converted into aromatic benzene. Here we break down the triple bond to be double and single, and this is called, as we know, polymerization. Polymerization. This is form cyclic. في another type of polymerization is called the linear polymerization. But this is cycle to form polymerization to form cyclic. We can call cyclo polymerization. Another name of this process. And here 3 molecules, 3 means tri. We can call this cyclotrimerization. Cyclotrimerization. Cyclic by 3 molecules. The same polymerization, cyclopolymerization, or cyclotrimerization or trimerization. This is a process in where we convert acetylene into benzene by strongly heating acetylene, 3 molecules of acetylene in red hot nickel tube. This is number 2 from hydrocarbons. Number 3 from, to get benzene from phenol. From phenol. Phenol C6H5OH. Here phenol OH attached to benzene ring. And we want to remove oxygen. When we remove oxygen from a compound, we call this reduction. We use a strong reducing agent such as divided hot zinc to take the oxygen to reduce the phenol into benzene and ZNOS form. This is called reduction. So reduction of phenol using zinc, divided zinc, to convert phenol into benzene C6H5OH plus Zn heat يديني C6H6 plus ZNO. This is the third method to prepare benzene. The last one may be used in lab to prepare benzene from sodium salt of benzoic acid. From sodium benzoate. Sodium benzoate, the salt of benzoic acid. Structure formula, benzene ring, COONA. This is a sodium benzoate plus soda lime, sodium hydroxide, mixture of sodium hydroxide and calcium hydroxide, heat to get benzene and sodium carbonate. This is the same method we use to prepare methane, and this is called dry distillation. Dry distillation. Take care, there are three examples of distillation: dry distillation, fractional distillation, destructive distillation. We can get benzene from sodium benzoate. This is the salt of benzoic acid. Benzoic acid, benzene ring, COOH. When we replace the hydrogen by metal, we call this as a salt. Sodium benzoate, using sodium hydroxide, calcium oxide, we call it the mixture. This is called soda lime, and this process is called dry distillation to get benzene and sodium carbonate. This is about the method to prepare benzene. Let's explain how to give a nomenclature of derivatives of benzene. Number one, the compound which is mono-substituted on benzene. Mono-substituted of benzene. For example, this is benzene ring, and this is Cl. I say that is phenyl chloride or chlorobenzene. Chlorobenzene. Whatever the position, there is no difference chlorine to be here in this carbon or that. This, like this, like this, like this. All carbon have the same ability to combine with chlorine to form chlorobenzene. We can say phenyl chloride, but let us to say chlorobenzene when one substituted on the benzene ring. Another example, NO2, this compound is called, or this group is called nitro. NO2, but this is called nitrobenzene. Nitrobenzene. C6H5NO2, here C6H5Cl. C6H5Cl, here C6H5NO2 nitrobenzene. This is when one atom or group attached to benzene ring. Disubstituted compound. Disubstituted compound in benzene, disubstituted, means that two atoms or two groups are attached to benzene ring. Let's see these examples. Here Cl, NO2. This is called ortho nitrochlorobenzene. benzene. Orthonitrochlorobenzene, and this is called ClNO2 para nitrochlorobenzene. The last one, Cl in this position, NO2, is called metachloronitrobenzene.
I have a question here. I have a question here.
Yes.
For the first drawings, the nitro group was ortho and para for the chloro. So the parent name is chlorobenzene and ortho nitrochlorobenzene and para nitrochlorobenzene.
Why?
While in the third example, the nitro is meta-directing group, so I call it meta-chloronitrobenzene. طب if I make substitution, يعني write ortho-nitrochlorobenzene, is it wrong?
Let's to explain.
Or ortho-chloronitrobenzene?
It can be
It
right.
can pass.
It can be right. It can be right. I will explain and
Because
why.
in the evaluation book
why.
they
Yes,
did this.
This is
They
my
did so. Yes.
But here are two problems. Number one, what's meant by orthoparameter? Why this compound orthoparameter? Why is called this? And how it get this orthoparameter?
Okay, let's start with this point and then answer the question.
Okay. And then here we say that nitrochlorobenzene, but here we say that chloronitrobenzene. Let's make the position of the benzene ring. Here the benzene ring, let's to make the first group A here. So we number the carbon of the benzene ring from A, number 1, 2, 3, 4, 5, 6. And when the B compound is attached to the benzene ring, which has A compound, it may be take this position, 2 or 3 or 4 or 5 or 6. The position 2 and 6 are called ortho. When the B is near to the A, the main group, we call this ortho. So the position 2 and 6 is called ortho. While position 4 here is called para. And the position 3 and 5, here 3 and 5 is called meta. So let's to see the three compounds. Here nitro in the position ortho because it takes the position 2, or here the position 6, and nitro in the position 4, so we call it para, and this is the position 3 or 5, if it was here 3 and 5, we call this is meta. So the position ortho, para, meta, depending on the number of carbon atom which the atom or the group attached. Number 2, why this compound may be ortho, para, or meta? This is depending on the main group here, E. There are some groups which direct the compound to ortho and para. We call them directing group. Directing group, the group shifts the compound, the second compound or the second atom, to the position ortho or para or meta. Let's to write this and give example. Directing groups. Directing groups. Number 1, groups direct or shift to ortho and para, ortho and para position. There are 4 groups which direct to ortho and para. Number 1, halogens, fluorine, chlorine, bromine, or iodine. When fluorine F or chlorine Cl or bromine Br or iodine is attached to the benzene ring, the compound, the group or the atom will be attached to this compound. Halogen shift the compound to position ortho and para. Let's write the 4 groups and then give example. Number 2, alkyl groups, alkyl radicals. We know that are alkyls, CH3 methyl group, C2H5 ethyl group, and so on. These groups shift to ortho and para. Number 3, hydroxyl group, hydroxyl group OH. When benzene ring is attached to OH, such as we take phenol C6H5OH, this group shift to the position ortho and para. The last one, amino group, amino, which is NH2. Also NH2 shift to the position ortho and para.
May I make it easier?
Example?
May I make it easier for the students? Let's say any group contain oxygen. It doesn't direct ortho para.
Except
So any group doesn't contain oxygen directs ortho para except OH. So make it as a rule. Any group doesn't contain oxygen directs ortho and para except OH because it contains oxygen and directs ortho para. So is it easier now? Any group doesn't contain oxygen atom directs ortho and para except OH group because it contains oxygen and directs ortho para.
When we take the second, it will be
easier. Sorry for interrupting.
Let's say, okay, this example. Maybe OH, hydroxybenzene. It is called phenol. When it reacts with halogen, bromine for example, Br2, it gives 2 compounds. Why? Because the OH shift in ortho, not the Pr. Here the OH on the benzene ring shift to ortho and para. OH, Br, OH, Br plus 2HBr. So we take 2 molecules of phenol and 2 molecules of bromine to form ortho-bromophenol and para-bromophenol. Para-bromophenol. Here ortho-bromophenol. So OH shift to position ortho and para. Take care, it gives 2 compounds, ortho and para. There are many examples about the ortho and para. Let's take the groups which direct to meta position. Number 2, groups direct to meta position. Any group has oxygen except, as the may say, except OH. Number 1, formyl group, or we call it aldehyde group. aldehyde group CHO. We take this when we explain oxidation of catalytic hydration of ethene, which form acetaldehyde. Aldehyde group. Aldehyde group, or formyl number 2. Ketonic group, C double bond O. This is ketonic group, or carbonyl. We will take these groups when we explain the hydrocarbon derivatives. Number 3 also contains CO, contains oxygen. Number 3, carboxylic group. COOH. Number 4, nitro group. NO2, nitro group. So aldehyde group contains O, ketonic group contains O, carboxylic group also has O, and nitro groups has O. When we take example to explain this, this is nitro benzene. NO2, it is called nitrobenzene. When nitrobenzene, when we make a halogenation, react with chlorine, for example. With chlorine, nitro shift in the position. This is indirect sunlight to make substitution. One hydrogen from position meta, this is nitrobenzene, and the chlorine is attached to position to carbon in the position meta, and HCl evolving. So it gives only one compound, which is meta-chloronitrobenzene. This is why we say that also nitrochlorobenzene, para nitrochlorobenzene, but in position meta we say that metachloronitrobenzene, because the main group which is direct in position meta is the nitro group. There are differences between groups which are direct in ortho and para. It gives two compounds, but here in position of meta it gives only one compound. There are examples for questions. Benzene exposed to halogenation then nitration, what is the result? And also benzene exposed to nitration then halogenation. Take care, when we make halogenation of benzene, it gives a halobenzene, and by nitration it will give two compounds. It form ortho nitrohalobenzene, maybe chlorobenzene, fluorobenzene, and para nitrohalobenzene. When we make nitration then halogenation, so it gives at first nitrobenzene, and nitrobenzene will shift in position meta. It called meta-halonitrobenzene. This is the difference between the two processes. So what about the compound has more than two substituted, 3 or more? Here we will use AUPAC system, the number of carbon. For example, Cl NO2 Br. We take the number of carbon to be the lowest sum of numbers, the lowest number. When we write the number, and when we number the carbon of the benzene from here, it will be 1, 3, 4. 1, 3, 4, the sum of this number will be 8. But when we take the number from here, 1, 2, 4, this will be 7. This is the lowest number we can make number from other sides, it will be more than 7. يبقى at first we take the number to let the groups take the lowest summation of the numbers. This is number 1. Number 2, when we write, we start alphabetic. So this compound will be 1 bromo dash 4 chloro dash 2 nitro benzene. يبقى at first we take the number of carbon to be the lowest summation of the number. Number 2, we write alphabetic the atoms or the groups on the benzene ring. يبقى this is about the 3 substitution or more on the benzene ring.
Could we substitute or could we write BR in the place of CL? يعني, and write the name again, please, because this point is a kind of confusion for the students. You said before that writing, يعني just we need to have the smallest summation of the numbers of the positions. So if I put the bromine up and let's make nitro down, yes, and the nitro is, yes, and the chlorine, yes,
near to the NO2.
Yes. How can we do it? So let's show it in the data show.
Let's do it here.
Okay.
Cl.
Why not?
Say we take the lowest number. If we start from here, it will be 1, 3, 4. From here, 1, 4, 5. Okay, we must take from this 1, 2, 4. 1, 2, 4. To be the summation of this number will be 7. And then we write alphabetic. Start with bromine. Bromine at 4. 4 dash bromo 2 dash chloro dash 1 nitro, then benzene. But as I said, at first we take the number of, we give the number of carbon atom to be the summation of the number, the lowest sum of these numbers. And when we write, we start with alphabetic. We take alphabetic. This is called 4 bromo 2 chloro, bromo before chloro before nitro.
I have another question. Let's draw a benzene ring and let's have 4 methyl group, as I'll show. One at the top.
Benzene ring.
Yes, at the top methyl group.
CH3.
Yes, and the next one is methyl. Yes.
Here.
Yes. Methyl.
CH3.
Yes. And at the para for the top one, yes, methyl.
CH3 also.
And the left is methyl.
Here.
I have a question.
Okay.
When I'm asked to write the UPAC name of this compound, how can I write it?
Okay. When I start from here, I will move to be 1, 2, 4, 5. 1, 2, 4, 5. They will be 12. Or when I start from here, and 1, 2, 4, 5. Or here 1, 2, 4, 5. The same. And this is methyl group. No? They are similar. But I will be write this. Take at first number, whatever 1, 2, 4, 5. It will be 1, 2, 4, 5 tetra methyl benzene. But let's change one of these.
Yes. Suppose it's nitro. My question is, suppose one student said that 2, 4, 5. Try 2, 4, 5. As you write 2, 4, 5. Try methyl toluene. Is it AUPAC or not? Or it's obvious in the example of the TNT. And it's a kind of confusion.
I understand what you say. Number 1, when we take toluene, toluene means that CH3 on the benzene ring.
since we're discussing the point of nomenclature.
I will explain. CH3, this is called toluene. This is a common name, not a IUPAC name.
IUPAC name is benzene.
IUPAC name is benzene, and the number of carbon atom. When we take the number of carbon atom, so we used IUPAC name.
يعني I can call this methyl benzene if I need the IUPAC name.
Yes.
Thank you.
But when I say toluene, it is a common name.
Yes.
Here, when I say that, if we take, for example, bromine or chlorine or nitro, whatever, say, مثلا, where, maybe, at first take care, CH3, because the C is attached to the carbon. So when we take, for example,
let's draw a new one.
Okay.
Let's draw. The best example of this is TNT, because it's 2,4,6 trinitrotoluene. How come they count and also at the same time use toluene as a common name? Because this is a question in the evaluation book.
Yes.
Right, the name of the IUPAC name of the TNT. So can I, let's do this example for the students because it's a very confusing point.
Okay. Here CH3, NO2.
Yes.
NO2. N attached to the benzene ring.
Yes, and
O2.
Yes.
Take care. Here this. We say that CH3 on benzene ring is called toluene. Toluene. Here nitro. So we start from toluene, number 1. From methyl, 1, 2, 4, 6. So the 3 group of nitro in 4, in 2, 4, 6. We call this 2, 4, 6 tri-nitrotoluene. This is called TNT. TNT, we will explain this explosive compound.
So we can write it as 2,4,6 trinitrotoluene, acceptable as an IUPAC name, or 2,4,6 we can write 1-methyl to MN. So 1-methyl 2,4,6 trinitrobenzene.
Accept the two.
The two answers are acceptable.
Because the common name will be...
because we have a lot of points not discussing expansion or extension in the syllabus of the students. So now this is the end of the nomenclature of all the compounds of benzene.
Yes.
So let's make another example for bromine, and we said nitro. We write the bromine first, right?
Yes.
Yes.
Because alphabetic.
Yes, alphabetic, whether the position, and then if I can count from it, it's okay. From the bromine. Thank you for being with us, Mr. Muhammad.
Thank you.
Thank you, dear students, for being with us. We'll wait for you for the next session. Assalamu alaikum wa rahmatullahi wa barakatuh.